This is group help. Our project is about financial time series prediction using deep learning. My name is Yo-Yo. This is the outline of the presentation. In the introduction, the time series analysis is important in lots of research topics, such as quantitative finance and econometric. So there are two methods to be used. First is statistical methods. Another one is machine learning method. Because the problem can be transformed into the classification problem, a machine learning algorithm can solve this problem. However, some kinds of machine learning classification approaches need good features to help to separate the training data, and the feature extraction is a big challenge in this work. So we choose deep neural network, which has the ability to extract good features automatically from the real inputs. The purpose of our project is to apply deep neural network (DNN) to predict the trend of financial time series. Is to utilize real financial data input, 1 minute resolution to predict the temporal trend of the China CSI 300 index in Chinese A-share market, and gives a trade following investment strategy, comparing its performance with benchmarks along 2 years backtesting. Our work mainly based on the paper Financial Time Series Prediction using Deep Learning. But we also make some different application details comparing with the original method in that paper, mainly in two aspects, classification and trading strategy. In the classification, the authors set the difference into two states. Given x and n belongs to z and the time interval t, the difference between the future price and the current price is the yn equals xn plus t minus n xn. However, in our case, under this classification, the model has a fault that when the absolute value of the xn plus t minus xn is small, it's impossible to make profits even when the model is completely accurate in real investment market, which will charge a trading fee. To overcome this fault, in our experiment, we set the difference into three states: increasing dramatically and decreasing dramatically, and others. In order to predict the future index price trend y caret n, we applied a classification neural network trained using the real prices data of the previous n minutes. The y caret n equals y caret n given x n minus n plus 1 to the xn. This picture is the flowchart of our deep learning-based financial trend prediction system. In the DNN structure, the author has tried a large number of structures of neural network containing the convolutional layers. However, it did not yield significant accuracy improvement. We assume the structure of neural net implemented in the paper is optimal one, which is shown in the figure 2. And also the layer 5 should be changed into 20 times 3 FC, and the corresponding output should be changed to 3 times 1, because we set the difference as 3 states, which is different with the paper. In the benchmark, In order to evaluate the performance of our trade following strategy derived from the DNN methodology, we develop a long and holding strategy as the benchmark to comparing the performance of both strategies over the 2 years backtesting period. Besides, I want to make an explanation about some finance terminology: long trade and short trade. Well, long trade means that buying a financial asset and hold it until you want to sell it. It's namely closing your position. Short trading, a more complicated one, represents that firstly you borrow a financial asset from others and sell it in the market, and then you must buy it back and to return it to the lender. In the opening position trade, we should use soft information to determine the outputs of softmax layer of the DNN represent the probabilities of future trade belonging to the respective classes. In order to use soft information P, Y given X provided by the DNN model to trade following investment strategy. In Arthur's case, he set the future difference into 2 states. It opens trade in the following method. Let O n belongs to Z represent whether opening a new position or not at time n. If it's larger than threshold, we should do the decision to open a new position, larger and equal to threshold. If it's less than threshold, we do not open a new position. For our case, since we set the future difference into 3 states, it would open trade in similar method. If it's larger than and equal threshold, we should do the decision to long position. If it's less and equal to threshold, we should do the decision to short position. If others, we do nothing. In the closing a position trade rules, since it's an intraday trading strategy, the strategy follows these rules to close its position. Rule 1. After 10 minutes, if the DNN model's predictions result is different from the signal when we open position, we choose to close it and wait to next signal. Rule 2. After 10 minutes, if the DNN model's prediction result is same as the signal when we open the position, we keep to hold position. Rule 3. During 10 minutes, if the loss rate of the trade exceeds a certain threshold, we choose to close it and wait for the next signal. Rule 4. When it's 1 minute before the closing time of the market, we choose to close our position since it's an intraday trading and we do not want to take overnight risk. This is our strategy structure overview. In the experiment and result, for the data collection and pre-processing, the proposed scheme were experimentally verified by using the market data of the CSI index given in 1 minute resolution, purchased from the Tonghua Sheng, which is a major financial information and a data supplier in China, based on regular trading hours. We eliminate days with partial trading hour. For the whole dataset, it starts from the January 4th, 2010 and ends November 19th, in 2019. As we study intraday trading, we divide the data into different trading days and extract all training instance and validation instance during one certain day. For a certain day, we could drive about 200 different data samples. To be more specific, the data of samples driven within a certain day is 60 times 4 minus m minus t, where m is the length of previous price vector and the t is the prediction time interval. We use the data after January 4th, 2018 to act as the back testing original data and the data between the January 4th, 2016 and December 31, 2017 to act as validate data and the others as training data. To make the numbers of instance of each class to be same, we resample the training dataset and its non-need for the validated dataset. Besides, we also analyze our inputs by subtracting the mean value and divide by the standard deviation. In the light of the labeling, for a certain day during the training time period, we choose continuum price series that have lengths of m which make a vector, and calculate the difference xn plus t minus xn using the formula to determine the class label. For the parameter m, we set it to 60. For the t, we set to the 28. For the parameter threshold, controlling the times of opening a new position, given that mu and sigma are the mean value and the standard deviation value of probabilities provided by DNN model on the validation dataset, we set it to be mu plus sigma. For parameter alpha and beta, we can see the distribution is symmetric, so we set alpha to be 75 the quantile value and beta to be 25% quantile value, which is 6 and minus 6 respectively. In the training DNN process, the neural network is built using Keras package, and we choose an algorithm to minimize the model loss, where mini patches of size is 100. The learning rate is 0.0001, beta 1 is 0.9, and beta 2 is 0.99. The training accuracy and validation accuracy is shown in this picture. In back testing process, we implement the back testing process based on the trade opening rules and close rules over the time period of January 4th, 2018 to the November 9th, 2019. The cumulative profits of our trained following strategy based on the DNN model and the benchmark is shown in this picture. In conclusion, during this project, we proposed two main improvements based on the works of the paper, setting the trade-off into 3 stages instead of 2 and adding to stop-loss method to the trade following intraday trading strategy. We also built and trained a DNN model using Keras package, developed a trade following investment strategy using soft information provided by the DNN model, and implement a back testing process to evaluate a trading strategy quantitatively, which outperformed to the benchmarks. Thanks.